what we have here, we have few files, and for example, let us call file 1 and with a size of 5 bytes, and file 2 of size say 7 bytes, and file 3 of size 3, and file 4 of size 10 bytes. Okay, now what we are saying is these files contain um, some data which is already sorted. Let us assume these files, they contain sorted numbers in them. My problem here is to merge all these files into one single file. What is problem? To merge all the files. And what I said is these files are sorted. So what they contain? The files sorted data within them. Okay, so the problem here is to merge the files. Now you all know that when I merge two files, for example, let me let me take a array. For example, if I have an array and it has few numbers 1, 7, 10, 20, 25, and if I have another array and if it contains 5, 9, 15, 19, and 30. Let us suppose I have this two arrays. Now first thing what I want to do is I want to sort, see, obviously they are sorted. This contain the sorted arrays within that, the elements are sorted within it, right? So when elements in this are sorted, and what I want is I want a new array which will contain all the numbers in array 1 and array 2. So what I want to do is I want to merge the contents of this array as well as this array. So if I want to merge them, uh, how many comparisons or how many operations you need? So in short, what I'm asking you is, what's the time complexity of merging two arrays or two lists or two collections? Let's call it as collection or two lists which contain sorted data within them. And assume that the size of this, for example, the size of this array, for example, the size of this is m, and the size of this is n. So if this is a case, what is the complexity of merge operation on these two lists? So if its size is m and if size is n, how many comparisons or how many operations I need to do so that the combined array contains all the elements from m, all the elements from the orange colored array, and it too contains all the elements in sorted order. I think this problem is merging two sorted arrays. So if that's the problem, how many comparisons or how many operations I need to get this resultant array, a combined array, which will also be sorted? Can I get your responses? So one, let us suppose if one has here in this case the size of this is 5 and size of this is also 5. Here m and n are both equal, both size are 5. So how many operations you need to do so that you will end up here with an array which contains all the elements from yellow colored array and orange colored array, that too in sorted order. Can I get your responses? So Gurnath has given it, he said it is m into n. Any other response? Do you think it is m into n? Let us see the logic how we can do that. So I'll first discuss the logic how we are need to do. So what I do is, I hope you have done this in merge sort. In merge sort, when we merge two subarrays in the divide and conquer method, what we do is I check this 1 and I check this 5. Whichever is lower, I first add it here, right? This is here. Then I check 7 and 5. Whichever is lower, I add it here. Then I check 7 and I check 9. 7 is lower. So the one which I add here, I just ignore that. So 7 I've added. So next two elements come to be compared are 10 and 9. Whichever is lower, it appears in resultant array. Then 10 and 15, which is lower? 10. Then 10 is done. So you compare 20 and 15, which is lower? 15 is lower. Then after to 15, you compare 20 and 19, which is lower? 19. Then you compare 20 and 30, which is lower? 20. Then you compare 25 and 30, which is lower? 25. Then once you're done with this, what you do is whatever are remaining from this, if you reach end of this, then whatever are remaining from this, add them as it is. The only 30 is remaining. So does this array contain all the elements from the above two arrays? Yes. Is it sorted? Yes. So how many operations I did? How many comparisons? So one response I got was m into n. Do you agree that it will require m into n? Or is it something m plus n? So to what complexity you will agree? M into n or m plus n? Remember, if I write, let's say, if I write here that the complexity of this is O of m into n, or if I write O of m plus n, technically, see, technically this is all, you are saying this is upper bound. You are also saying this is upper bound, but I want the closest upper bound. This is like taking a very large guess. This is like taking a very calculated and correct guess. So what I want is, in order to make easier, if you feel your answer is m into n, type 1 in chat window. If you feel the answer is O of m plus n, type 2. So I just want to see your answers. So what is the complexity of this algorithm, which right now we saw to merge two sorted arrays? Is it m into n? If it is m, type 1. If you feel it is O of m plus n, type 2. Yeah, so I see 2 as a response, yes. So the right answer is O of m plus n. Right, that's the answer for this. It is O of m plus n. Now, just want to say, I hope Gurnath has understood that why it is m plus n, why it is not m into n. Okay, so if you look at the way we solved, it is m plus n, right? So understood what merging two sorted arrays. So when I say here, let us, instead of calling arrays, let us call it as file 1. File 1 contains 5 elements, and let's say file 2 and it contains some element. My question is to add all this. So what I am trying to do, what this problem is asking you, you have merged two files. That's fine. Now, if I want to merge more than two files, this problem can be slightly different. Okay. So can you tell me, if I want to merge, for example, let's say m plus n, you need m plus 1 operations. It could be read operations, scan operations, it could be any operation. Let us consider scan operations. So it requires m plus n operations to merge two files. If that's the case, and if I have file 1, file 2, and file 3 and file 4, let us just consider file 1, 2, and 3. Now, if I just consider file 1, 2, and 3 for time's sake, let me let me just identify them in some different color. So what I'll do is I'll just consider file 1, 2, and 3. If I consider file 1, 2, and 3, what is your options here? So how many total number of operations I'll require to merge file 1, 2, and 3? Now, since you have this option of merging 1, 2, and 3, you have few permutations to try. It could be case you will first combine first file with 2 and then you will combine the merged file with 3. This is one order. Okay, this is one permutation, right? This is one permutations to try, right? And you have to find out how many scan operations it will require, right? And in permutation 2, so let's call it as uh, let's say permutation A, and this call it as permutation B. So in permutation B, what I'll do is I will first merge uh, file 3 with file 1, and then I'll merge that with file 7, right? And I'll also take permutation C, where I will merge, let's say I will merge file 3 with file 2, and then I'll merge file 1. If I do merge operations in this order, does it affect total number of merge required to merge all these three files? So for example, if I merge 1 plus 2 plus 3, what is the size of first file? 5. So to merge 1 plus 2 files, you require 5 plus 7. What is 5 plus 7? 12 merge operations. So now you have a merge. For example, if I talk this, then when you compare 1 plus 2, remember, this will result a file with size 5 plus 7 at 12, right? You will have one file with size, a merged file of size 12. Now this merged file of size 12, it has to be now merged with file 3, whose size is 3. So what will be the total value for this? Total merge operations required for this permutation 1, it would be 12 plus 3. So what 12 plus 3? How much it turns out to be 15. So total operations required to merge file 1, 2, 3 in order, like first file merged with second file, you get one combined file, and now this combined file is now merged with the remaining file, which is third file. Likewise, for permutation 3, what are the first two files you're combining? File 3 and file 1. What is file 3 and file 1? What are total number of merge operations which will be required to merge file 1 and file 3, which is 5 plus 3, which is 7. So here you will get a 7, and then this 7 has to be merged with file 2. Remember, this is file 2. I just said it is file 2, whose size is 7. So the total number of operations to combine these three files will be 7 plus 7, which would be 7 plus 7, which will be equal to 14. Right? When would I get this 14 operations? So if I combine these files in this order, means file 3 has to be combined with file 1. Then this combined new file, which is a result of combining file 3 and file 1, this will now be merged with file 2. Right? So as for permutation 3, can you tell me what will be total cost? Can you calculate and tell me the way I will calculate it for permutation 1 and 3? Okay, here I think I have 3 and 1. 5 plus 3 is 8. So 8 plus 2, 8 plus 7, I think it would be 15. I just miscalculated here. I hope understood this. Okay, and for 3 plus 2 plus 1? So what is file 3 and 2? 3 and 2. What you get here is 10. Here you get 10, and this 10 will now be merged with a file of size 5. This will be merged with a file of size 5. Okay. Now let us do one thing. I think something wrong we have done. If I do this, let me tell you what is wrong we are doing. So first merge operation 1 plus 2, 12 merge, and then you are merging 12 plus 3. So how many are total merge operations? So total merge operations for combining first 1 and 2 files, the total merge is 12. Then how many comparisons you did to merge 12 and 3? 15. This is what you have done. And here in this case, to merge first two files, 8 merge operations. Then to merge this combined with the remaining file, how much total merge operations you will do? 8 for combining first two files, then combining the combined file with the remaining file. So it is how much it is? It is 8 plus 7, which is 15. So this gives you, right? So this 15 is actually a result of 8 plus 7. So likewise, if you do it for 3, what is total number of comparisons here? To merge first and second, you require 10, and to now combine the combined file with the remaining file, how much it would be? The combined file size is 10 and remaining file is 5. So 10 plus 5 is 15. So total merge operations will be this. So what's the value of this? 27. What the value of this is 23, and this is should be 25. Have you understood how we have arrived at these numbers 27, 23, 25? So this 12 is nothing but for combining file 1 and file 2. This is for combining merge F1, F2 with F3. I hope you're getting this. How did I come to this second number? So when I say F1, F2, this is nothing but the size of combined file. When I'm saying F1 and F2, they're not referring to these file order. These are referring to the here the F1, F2, the first file to be merged, second file to be merged, and third file to be merged. And the size of first file here is 5. Size of second file is 7. So this 12 is nothing but it's a value of F1 plus F2. So here if you see what is 8. So third file means size 3. First file means 5. So the size would be 8. So the size of the merged file here would be 8. So are you have you understood this? Have you understood? I have a question from Magas. What he is saying is why we are not using merged file F1, F2 for second operation F3. I'm not getting your question. So what are you asking? Can you be little bit more specific? I didn't get your question. I think Akash has put a question. What he is asking, we are not using the merged file F1, F2 for second operation. I'm not getting this. This is what I'm using this, right? The first, see here the order in which I want to merge is third file has to be merged with first, then the combined file has to be merged with second. That's what I'm saying, the order of merging the files here. So if I combine third file with first file, obviously it takes 8 comparisons. Now the combined file size would be 8. So the combined file size 8 will be now combined with the second file, which is 7. So 8 plus 7. I think some need to check. I'm not getting your doubt. So the total would be 8 plus 15. Yeah, we are using the same. So when you're saying used merged file of first operation for merging third file, yeah, we are using the same. So you see, you will better understand this if I draw a diagram. For example, let me so these are the two files which I'm talking, right? And let us say this is the size of file. So let us consider the size of first file. Let me consider this permutation B. For permutation B, I'm talking about. What's the size of first file? The file I'm considering is third file. The size of third file is 3, and the second file I'm considering is file 1. The size is 5, right? Then the third file I'm considering is second file, which is file 2, whose size is 7. So what I'm doing is I need to merge in this order. So if I merge them in this order, then what will be merge of this both operations? So 3 plus 5 is 8. So I've already merged this file. So once I merge this file, remember after merging these two files, I get this. Okay. and the content of this merged file, now this two will be merged, right? This 8 plus 7 will be merged. If I merge this two, so if I merge this two, so I'll be getting one more merge here. What it would be? It would be result of combining 8, and it would be result of merging this two. So if I merge this, the size of combined file is 8, and what's the file of this file? 7. So what it is? It should be 15. So then what's the overall size of total merge operations? The total merge operation is the sum of boxes with yellow colored boxes. So first I require 8 operations to merge first two files, then 15 to merge third. So total will be 8 plus 15. So what is total 8 plus 15? 23. So we have arrived at these numbers by using the same logic: 27, 23, and 25. I hope you got that. And I hope have you all understood why it is 27, why it is 23, and why it is 25? Have you all understood? Okay. So so the what point we are trying to make here is, if I want to merge these files, what I found is the order in which I merge these files, that decides, or that has a control over total number of file merge operations. Now my problem here, as I said, is to merge all the files with minimum number of operations. This is my problem. We have to merge. I know how to merge them. We have a logic to merge, but the constraint here is I need to merge them with minimum number of operations. And when I say minimum number of operations, what we have found out that the order in which these files are being merged, the order in which the files are being merged, it decides the total number of operations. So can anyone guess in what order I need to merge this file so that I get a minimum operations? Can anyone guess what should be that order in which we have to merge these files such that that minimizes the total number of operations required to merge all the files? We have seen three such order by looking at the three permutations here. Permutation 1, I tried to merge first file, second file, and third in file 1, file 2, file 3. In B, I'm trying to first merge file 3 with file 1 and then file 2. In permutation C, file 3 with file 2 and then 1. So which order is giving you the least operations? It's 23. And can you guess in what order we have to combine the files so that we get the minimum operations? Yeah, so as it is said, once again it would be in the ascending order. So we also call ascending order as non-decreasing order. And when I say ascending order, it should be in the ascending order of file merge operations. So ascending order of file size. I hope you're getting this. So what is the solution? You have to merge these files in an order, and this order should be in ascending order of the file sizes. That gives the solution to the problem. So this is almost similar to yesterday's problem. Yesterday we had optimal storage on tapes. Now we are looking at optimal file merge pattern. I hope you understood this pattern, right? Have you understood this? Shall we look at a Python program to solve this? The Python program will be a little bit interesting. Okay, so now let us write a Python program. Okay, so I've just opened Python PyCharm window. It will open in few seconds. Before it opens, I want to ask one more quick question. What can I use? What will be problem when I convert this into Python? Do we need to actually sort? So what I want my Python program to give me this value 23, 5. So I'll give my Python program a files order of a files with some sizes. It has to give me in a minimum number of operations with which it can combine these files. So as we have seen in yesterday's lecture, uh, if we can try all the permutations and find minimum amount, that yes, but that's a brute force approach. We don't want that exponential kind of algorithm complexity. So I need to find the best possible approach to solve this problem. Let me share the Python window. Okay, so now let me create a new file. Call this optimal file merge. Called optimal files merge. Okay, so what we will do is we'll consider I'll have a list of files. Let's say this list of files contains files with size. For example, we'll take from the same example 5, 7, 3 and 10 from our problem. So the first file size is 5, the second file size is 7, and third file size is 3, and last file size is 10. So what output I need to print? This would be an input to my algorithm or a program. And what I'm expecting as an output. So output will be minimum number of operations. Okay. So where should I start? How should I start? I have an input which is inside files. So as per the logic, what I told you is you need to merge them in the order of this. So in the order of file sizes. So what would you suggest? Would you suggest me to sort this? If I sort this, uh, see, the problem here is if you sort this, let us suppose I have sorted underscore files is equal to, for example, let me also make a sorted version of this files, right? If I have this, I will, for time being, I'll print files, and I'll also print sorted files. So if this is the case, so you get sorted one, and now I need to add this. So how would you approach this? So what you do is you will merge, you will do an addition of first two, 3 plus 5. So when you do 3 plus 5, what is the resultant operation? So I want to tell you what the problem is that. So if this is an output, what you're doing is you will merge first 3 plus 5. So what that will do is that will make next operation to consider 8, 7 and 10. Then this is a case, what you need to do is you need to merge next two minimum, right? You have to always merge the two minimum files. So here if you merge these two minimum files 8 and 7, you get 15 and 10. You will merge this 15 and 10, then you will get a value. Then you need to combine. Okay, you will combine this, that's fine. Now what if this file has one more, what if this has one more okay, 1 and 5. Let us consider I have 6 files with size 5, 7, 3, with size 10, 1 and 5. If I have this, then the sorted order of that would be 1, 5, 5, 3, 1, 3, 5, 5, 7, 10. See, that would be of this order. Sorted order will be. So if this is the case, what you will do is you will first merge 1 and 3, right? When you merge 1 and 3, you will get a new files with following sizes. So 1 and 3 are merged, and that will result into a file with size 4. And when you have this, the next merge you will do 4 and 5. When you do 4 and 5, that should give you a new file of size 9 and 5, right? At this point, what would be the next merge? Would it be 9 plus 5 or would it be 5 plus 7? I hope you're getting the problem I wanted to create here to show you what could be the problem. So as I said, we have to always merge the files with minimum size first. That's one thing which we have seen here. But if I go for that approach, and if I just go on the basic approach of sorting and merging that in order, that might not be the correct way. What you need to do is you need to also take care the size of intermediate files being created. So this is 1, 3, you got 5, 4, 5, 10. You have merged 4, 5, then you got 9, 5, 7. These are the files. Now, when you have file of this order, what should be the next merge? Would you do 9 plus 5 or would you do 5 plus 7? Let me see your responses. Okay, as Shubham has said, it should be 5 and 7. Yes, we won't merge 9 and 5. What we need to do is we need to merge 5 and 7. So if we merge 5 and 7, what will be the resultant one? 5 and 7 will be 12 and 10. Now what would be the next merge? Now what should be the second merge? 9, 12 or 12, 10 or 9, 10? It is 9, 10. So when you combine 9 and 10, you get 19, then you have remaining 12. Okay. So if I want to implement this logic, what I can do is, see, I have this array, right? Then I have this is sorted. But the moment I am at this point, this is no longer sorted. So if I want a good Python logic, I need to sort it, right? So I have to sort it. Then I'll get, if I sort this one, I'll get some order. For example, then if I sort this, the order might be 5, 7 and 9, 10. In this case, you can merge first two. If you combine first two, the order you will get is 12. You will get 12. I think here I already wrote it. So you will get 12, 9, 10. You will actually get 12, 9 and 10, which has to be sorted. And that will give me 9, 10, 12. Now what you'll do is you will merge these two. That will give you 19 and 12. Then you have to once again sort it. If I want a specific logic, you have to sort it. That will give me 12 comma 19. Then you add that. Then you get a final answer as 31. That's how you get it. Now, before I write a program, can I get any good solution to this? See, if I keep on sorting it, sort it, sort it, sort it. So here I have a sorted. This is giving me complexity of n log n. Sort operation is n log n. So if I do sort operation here again, n log n. If I do sort operation n log n. If I do sort operation roughly n log n. So you are almost ending up at the worst of worst, your complexity of algorithm ends as n times. N times you are sorting it with n log n. So the complexity will become n square log n. But can we avoid this? Can we avoid this? So can we avoid this repeated sort operations? What I need is I always want first two minimum operations of this. So this is a structure. I have to pick two minimums from this. Whatever the new element I get, I need to add back to this array. Then once I add it, I again want first two minimum. You will merge that. The resulting value, you will add it to this array. You want two more minimum. Whatever result you get, add it. You get two more minimum. So you remove them, add them, add the result back into this structure, then remove next to minimum, then whatever you get, add it, then you remove minimum, then you keep on adding. So when you keep on adding, remove, a stage will come which will where it will only contain one element in that. Then that would be the minimum number of operations you do it. So for this data structure, for this operations, I think we have seen one data structure for this, which will always give me a minimum element, and I can dynamically add or remove elements from it, and I can add an element with O of log n, I can remove element from it with O log n, and every time it will give me the minimum element. What is the data structure which we have recently saw? Yes, it is heap queue, right? So now do you agree that instead of calling sort, 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 I can use a very efficient data structure called as heap queue. So for heap queue, what I need to do is I need to heapify this list. So instead of sorting them, remember, instead of sorting it, what I'll do is I'll heapify it. Then I will remove one element from it. And actually what I'll do is I'll remove two elements. I'll get first minimum, second minimum, I'll add that. And once I add, this will be stored in heap back. Then I'll remove two. It will keep on repeating that. Okay, so now let us repeat that logic. So I'll just comment it. So I hope you'll use this for later. So we don't want this approach. Rather, we will prefer a heap based approach. So as I have said, we don't even need to sort. Okay, so I have files. We have print files. Then I'll just remove this. I don't think we require that. Okay, so I have files. Then I need to heapify it. What should I import? Import heap queue. You need to heapify it. How do I heapify that? So heap of files is equal to how do I do that? Heap queue dot heapify. Uh, this would actually do that. So what I want is I want to create a copy of this files. So since it only contains basic elements, it doesn't contain list of list. I will create uh, heap underscore files is equal to, I'll just create a new list from files. Okay, and then I will heapify this heap file structures. Okay, I hope you're getting this. I'm creating a copy of that and then I'm heapifying that. So this operation will heapify this list. Okay, so once I do this, what you need to do? You need to iterate. Okay, while length of heap files is greater than 1, as long as the length of this is greater than 1, what I need to do? I need, so let me also take total operations. Total operations is, let me initialize it to 0. So what I do is I remove two elements from that. So what I'll call it is file A is equal to the first minimum from this. How do you get the minimum from this? How do you remove element from this list? It is heap queue dot heap pop and provide this heap files. That will pop me a first file element. Then I'll repeat the same. I'll get the first minimum from that list. Then I get the second file B, right? So the first minimum and second minimum. Then command both. So what you'll get? You'll get file C is equal to, you need to merge. So file A plus file B. And this file C now should be added back. Where should I add this file? I need to add this file to this heap files. Remember that file A and B, you have, when you call heap pop, it removes them from this heap files. And you need to add a new element to heap files. So if you want to add a new elements, what you need to do is, what is the operation? Heap queue dot heap push. Push will add element to this element. What is that heap structure? Heap files. To this you need to add files. Okay. So when you add file C, yes, what you will do is you will go back to this while loop. You will once again remove 2, you will add. And this operation keeps on repeating, when you till you end up to a point where your heap just contains one element. And the moment it contains one element, at the end you need to just remove the, okay, now tell me, how do I do the total comparison operations? Do you think I need to maintain this total comparison operation? I don't think I need to do this, because every time I am adding, okay, I think we need this, right? When you do this operations, I need to do a total operations. Total operations is equal to total operations plus file C. Every time I need to do this. At the end, you have, once you come out of that, you need to do one more final one more. So the last element would be the last element. So last would be dot heap q dot heap last pop heap files. So remove the last one. So I will be coming out of loop when it has one element. Come out the last number of merge operations. Add it to total operations. That will get you the total operations for this. So it should give me a total operations here. That to the minimum one. Now I'm not sure what would be the minimum. Can you calculate the minimum operations for this? Let me do print operation. Okay, I get some index out of bound, index out of range. Where I'm getting it 7. So if I am getting this at 7, what wrong we have done? Okay, let us do one thing. It's a good way to debug this. Let me put a breakpoint and I'll debug that. Okay. I think I have, as Akash has pointed out, I think this is something I have done wrong. It is just heap push, not heap push pop. Sometimes when you're choosing this auto suggestion, make sure you have selected a proper function. Okay, so it is showing 106. Is it 106? Do we agree with 106 or it is something less than that? Can anyone calculate the total number of merge operations for this? Okay, let us do our logic like we had calculated for simple test case. What was that? I think 573. For this we have calculated there. And for that, if I am not wrong, 573, the minimum is 23. I'm getting 38. I think something I'm doing different. So first is heap, then heap pop, then I add C to this. So it is 8. 8 should be added to this. So why I am getting, maybe the last operation is something wrong. Yeah, 75 should be answer. I too don't agree with that. Let us debug if it is working as per our operation what we said. So I'll put some breakpoint here. Okay, I'll put a breakpoint and let us debug that. Debug is the best way to. Okay, so I have heap files. File A and file B means it took the first two minimum, right? It has added that. After adding that, the total operations are 8. Yes, fine. For total operations 8. My execution stopped at this point. I'll hit F7. Then I'll be doing heap push. So what is inside heap? Heap is only containing 7 because you have removed 5 and 3. So when I do this, it is 7 and 8. Okay, so when it is 7 and 8, Uh, okay. Then you get this is 7. You get this is 8. So you can see file name is that. File C is equal to both 15. So heap is empty. Then heap push 15. Length is 1. I'm coming out. So the total operation is 23. I think do we need this? Do we need this? I think when we do all the merge operations, the last is the one. I don't think we need this because total, I think we should stop at this point. Yeah, so I think we are adding the last element twice. I think we don't need that. We'll just stop this. I don't need this operation. So this should be enough. Let me execute it again. So for this, it should get 23. Yes, we are getting 23. And as for earlier test case, I think it should be, I think if someone has calculated, let us see what it is, 75. Yeah, the 75 is the right answer for that, right? 75 is right answer, I guess, for this file. 75 minimum operation. Okay, so any other test case we want to try? Let me see if I get any test case somewhere. Okay, I got this test case here. I took it from net. Let me see if this gives me a right answer. Yeah, right. So for this, the answer for this test case was 68. I'm getting 68. So we have a right working program. So I hope you understood what we have been doing that. So now if I want a complexity of this, see what is the complexity of this heapifying? Heapifying, that is n log n. That's the complexity of this heapify operation. Then whatever you're doing, what you're doing here, you're doing pop push. You're doing pop push, pop push. Each pop will be log n. Inserting and deleting is log n. So you are doing some log n's here. And for example, this is log n. Complexity here, this operation is log n. The complexity of this operation is log n. And the complexity of this operation is also log n. So removing or adding any element to a tree based structure is always log n. And this entire while loop, how many times this while loop is expected to run? At the worst, n times. So this is 3 log n. So the total complexity would be the n log n for first heapify. So this is the operation for heapify operation, right? Plus n times I am doing log n operation, n times I am doing 3 log n operations here. So n times I am doing 3 log n operations. So what's the overall complexity? N log n plus 3n log n. So how much it is? 4n log n. So 4 times n log n. So what is O notation? O will be, constants are always ignored. So O will be n log n. So the entire algorithm of optimal file merge can be solved as n log n. Now, if you compare this with our earlier sort operation, the sort based operation, so this was possible because we have used heap. But if I use that sort logic, the complexity would be n square log n. Which is better, heap based approach or sorting based approach? Which should be preferred, the heap based or sorting one? The heap based complexity is n log n, and this is O of n log n. Okay, have you understood this example, the file merge, the program? This is a classic example of application of heap data structure. And moreover that, this is a classic example of what is the use of heap queue and heapify procedure in Python. Remember, if I ask you to implement same program in C language, just imagine how many lines of code you are supposed to write. So here, if I consider the total number of lines of program, so see, if someone asks you what's the number of lines of code for this program, would you count from line number 1 to 23, line number 20? What is the logical way to calculate the line of code for a program? So in how many lines, what you will say, what is the line of code for this program? Would you calculate 20 lines of program? No, we do not calculate 20 lines of program. What we go is we only go on logical lines. What is the most logical operation here? This is one line, AP5. Then what is the other two? 2, 3, 4, and 5. So this program is logically a 5-line Python program. That's it. This program is 5-line Python program. Can you imagine what would be this? What would be this line in C? In C++, it would be less. And what would be it in, for example, what would be it in C++ or Java? Obviously, C will have more number. This would be slightly less, and Python you have far less than C++ and Java here. So this is one of the example why most of people prefer to use Python, because it's the ease of coding. This ease of coding is one of the very major advantage what Python gives to us. And when I say you are a good Python developer, it is not based on how many modules or functions you remember. It is based on how you can relate your algorithm logic with the Python's built-in functionality and the utility function Python gives us. So you see that it has given pop, push, very elegant way. Heap implementation was given to me. Okay, so now I hope you are in a better position to understand what exactly is the use of heap queue and why it is min heap. This is always it's a min heap. Instead of just seeing some sample program and saying this is heap, this is syntax, this will help you remember what exactly is the role of heap in Python. Okay, so have you understood this program? The entire concept, the file merge pattern and this program? Let me in your chat window. Okay, so yes, okay. Okay. Yeah. So the intensity with which I see the yes message, that tells me how attentive you are and how well the lecture went. So in a lecture, if I don't get the yes with the speed at which you are right now typing, that's the indication that you might have felt that lecture a little bit hard. So I'm glad that you understood this program. I'm glad that you understood this. Okay, so as a homework, I will ask you to print the order of file as well. So here I have given you total operation. My homework to you is to print the order of files as well. Let us see, this is just a few 1 or 2 lines of program here. We will discuss this in Telegram group. So today, tomorrow, till Friday, right? I hope you can work on this. homework is to print the order of file as well. See how optimally and how efficiently you can find this one. Okay, so that's it for today's lecture. Let's meet on Friday then. Okay.